Hello. So I'm going to go over some of the limiting reactants problems with you. Just forewarning, this might have to be like paused and restarted because there's some terrible, disgusting smell in Miss Flea's room next door, and it's like all over the place. So somebody's coming up to look at it. So anyway, they might pop in here because our rooms are connected. So anyway, I'm going to go ahead and go over the limiting reactants problems. And if you watch the video lesson from that day, like just limiting reactants, then the very last part of that, there were 3 slides. Okay, there's like plain white slides with like steps A, B, and C on it. That's exactly what the limiting reactants questions are over. And the very first problem on that assignment is almost identical to that example. The only thing that changes is like one mass. So I'm going to go ahead and go through number 2 with you because the first one's very similar. So let's go ahead and do number 2. So I couldn't figure out how to get like the question up on this board at the same time. So I have my question over here that I'm looking at to read off. So on the number 2, it gives you the balanced equation. Okay, so it gives you, not writing up too high. We have 3 calcium carbonates plus 2 iron phosphates, which yields 1 calcium phosphate and 1 iron carbonate. Oops. Move that over. CO3. Okay, so we have our balanced equation. That's already given to you, which is nice, so you don't have to do that part. So we're answering 3 questions. So on these, first thing you want to do is find the limiting reactant. The second thing you want to do is find, what was it? Oh, the maximum amount of each product that can be produced using that limiting reactant. And then the third question is how much of the other reactant, the excess, will you have left over? So the whole idea with limiting reactants is that you are starting with a certain amount of substances, and one of those substances is going to get completely used up in the reaction, and then you have nothing, no more, so you can't continue the reaction. So if you use up part of it, you're going to have some of it left over on the other one. So it's kind of the same way with like if you put a whole bunch of sugar in your iced tea. Okay, so you have iced tea and then you have sugar. Those are your 2, we'll call them your 2 chemicals in your reaction. You mix them together, you know that it's going to dissolve and combine. But if you put too much sugar in it, it's not going to react because there's not enough tea to fully dissolve in. So you're going to have excess sugar left over. So your limiting reactant in that case would be the tea. So you would need more tea to fully react all of the sugar. So that's what we're doing just on a chemical scale. So we have chemical equations to guide us for that. So you always want to start out with a balanced chemical equation. Like I said, this one's already balanced for you, but you might see it where it's not balanced. So you might have to start back with like a more of a true stoichiometry problem where you're having to write the equation first by, crisscrossing your charges and all that, all those rules we learned for writing formulas last semester, and then balance it, and then you can get started. So on this one, let me get a different color here. So on part A, you have to figure out which is going to be the limiting reactant. So in this problem in particular, the question tells you that you have 100 grams of the calcium carbonate to start off with. And then you also have 45 grams of the iron 3 phosphate. Okay, so if we're starting with these 2 amounts, if you're relating it to like the iced tea and the sugar, we have to figure out which one is going to stop the reaction from happening. And it's not always the lower amount. Okay, so just because there's less of the iron phosphate doesn't mean that that's going to be the thing that limits your reaction. Because if you look at this equation, you need more of the calcium carbonate than you do the iron phosphate because you need 3 moles for every 2 moles to make this reaction happen. So it's very possible that the calcium carbonate could be your limiting reactant. So we don't know. We have to do the math to figure it out. So what we're going to do is a mass-to-mass stoichiometry problem to figure out which of these reactants starting produces the least amount of the same product. Okay, so for this step, you pick one of your products to convert it into. Doesn't matter which one. Okay, so if you're looking at the key on Canvas, for this one, I chose the calcium phosphate to convert it into. You would get the same answer using the other product. So that part's up to you. Let this thing catch up. I see it lagging. It's not at the same speed as my face. Hold on. Okay, so hopefully that's better. Hopefully this turns out okay on your end, and my face and my speech is all at the same speed. But anyway, so we're going to pick one. I'm going to pick calcium phosphate because that's the one that I had done before, so I'm just going to use that one again. So you have to start out with 100 grams of calcium carbonate and do one whole problem for that. Then you start out with 45 grams of iron phosphate and do a whole other problem for that. So for this one, we're going to start out with your 100 grams of calcium carbonate. Okay, we're going to make our box. We need to turn this into grams of the chosen product. Okay, so I'm turning it into grams of this. So we know we're going to have all of the steps that we're going to have to do all of the steps to get from point A to point B. So we're going to have to convert it into moles, use the mole ratio, and convert it back to mass. So here you have grams of calcium carbonate. So grams of calcium carbonate goes on the bottom. You're going to have to add this up on your periodic table. Okay, so you add up 1 calcium plus 1 carbon plus 3 oxygens to get your mass. So that mass is going to be 100.06 grams of calcium carbonate. Okay, we know that the mass of anything is equal to 1 mole. So we can put 1 mole of calcium carbonate on the top. All right, so now grams of calcium carbonate has canceled. We're in moles of calcium carbonate now. So you want to now pull moles of calcium carbonate down here, and this is our opportunity to use the mole ratio. Okay, so we know that calcium carbonate compared to the calcium phosphate, which is what we're trying to turn it into, it's a 3-to-1 ratio. Okay, because there's no coefficients on this. That just means there's 1 mole, like 1 mole of it. So you'll have 3 moles of calcium carbonate, okay, and you're going to set that equal to 1 mole of the product that you've chosen. Okay. It's getting a little messy, sorry. So now the moles of calcium carbonate have canceled, and you're in moles of calcium phosphate. That's fine. It's asking you for mass. We want to get all the way to mass. So we're going to go ahead and convert this back to mass. So we know, just like we did here, that 1 mole of anything is equal to its mass. So we're going to set that equal 1 mole of the calcium phosphate equal to the mass of calcium phosphate. So that's going to be 310.10 grams of calcium phosphate. Okay, so at this point, your moles of calcium phosphate have canceled. Now we're in grams of calcium phosphate. That's what we wanted, and you're done. So you can just solve this mathematically. So you would multiply everything across the top, multiply everything across the bottom, and then divide the two. So for this one, kind of running out of space here, but we're going to end up with 103 grams of the calcium phosphate. Okay, so that's the answer to the first part of this. This is fine, but this doesn't answer the question. So for part A, it's asking you which of these is the limiting reactant, like which of these two. So we know that 100 grams of calcium carbonate is going to give us 103 grams of this product. So now we need to take the other given, which is the 45 grams of iron phosphate, and convert it into the same product and see which of those two chemicals was going to produce the least amount. So whichever one's going to produce the least amount is the limiting reactant because it can't produce any more than that. It's going to be all used up. So we're going to go ahead and do the same process for iron phosphate. Okay, so this is up here for you now. I went ahead and just paused it so not to take another 5 minutes of your time. So it's exactly the same question, right? So it's the same as this top one. The only difference is that we are going from calcium carbonate on this one, and we're going from iron phosphate on this one. So as you work across, you're still converting it into moles. using your mole ratio, and then converting it back to mass. This end has to be the same because you're converting them into the same product to compare the two. Okay, so if you look at the results here, the calcium carbonate is going to make 103 grams of your product, and the iron phosphate is going to only produce 46 grams of your product. So based off of this, we know that the iron phosphate, this one, is going to be the limiting reactant. So everything from here on out has to start from the 45 grams of iron phosphate because that's the limiting reactant. Okay, nothing, once this is used up, it doesn't matter how much you have of anything else because it's over. You can't make any more product with it. Okay, so to answer question A, this is going to be A, this is your answer. Okay, so we're doing two math problems. We're comparing all of the reactants to the product that we've chosen. Whichever product you choose doesn't matter as long as it's consistent with these two in the first part. Okay, so even if you compared them both to iron carbonate, you would end up with the same limiting reactant. Okay, so for A, that part's done. So we'll kind of just draw a line here. So for B, now that we know what our limiting reactant is, B is asking you to figure out how much of each product can be produced using that much limiting reactant. So if I only have 45 grams of iron phosphate, how much of each product can I make? Well, you already did that here for this product, okay? So on the very first part, you figured out how much of this product you can make. So that's already done. So you can just write that in there. You know that the calcium phosphate, you can only make 46 grams of it, okay? So using your 45 grams to start, you can only make 46 grams of this product. So you would want to just indicate that, like write that under B. You also have to figure out how much you can make of the other product that you didn't pick the first time. So we're still going to start with the limiting reactant, and we're going to do the same type of problem. The only difference is that you're going to convert it into the other product this time. Okay, so let's do this one. Okay, so I went ahead and wrote this one out for you. So like I said, you're still starting with the limiting reactant because now we've identified it. So the first part's identifying the limiting reactant. It's whichever one produces the least amount of your chosen product to convert it to. Now that we know the limiting reactant is the 45 grams of iron phosphate, B is asking how much product can you produce with that? So you've already answered that for this product, the calcium phosphate here. Now we need to figure out how much of our other product, the iron carbonate, in the second part here. So we're starting with the limiting reactant, converting it into moles, using the mole ratio, converting it back to mass to determine that we can make 43 grams of iron carbonate using this much of our limiting reactant. Now the last piece is going to be figuring out how much of the other reactant will be left over. Okay, so we've already figured out that this is our limiting reactant. It's going to be completely used up, which means we're not going to be using up all of this. All right, so we need to figure out how much of this is going to be left over when we're done. Okay, so I'm going to erase part of that. You know what? I'll just kind of lower this down. So we have a little bit more room down here to write. So we'll just go ahead and tack this on down here underneath. So for C, since we're comparing, let's put it back up here. So since we're comparing these two, you are going to start with your limiting reactant again, same way you did here. So once we've identified it, we stick with that to start with. So we'll still start with the 45 grams of iron phosphate, but this time we're going to convert it into the other reactant. Okay, so that'll tell us how much is going to be used up. Okay, so like I said, we converted our limiting reactant into the other reactant now. And so this is going to tell us that we're going to use up 44.79 grams of calcium carbonate. Okay, so if we have 45 grams of iron phosphate, we're going to use 44 grams of calcium carbonate. That's not the answer to C because C is asking what is the excess left over. Okay, so if we're using this much and we started with 100, you're just finding the difference. So here I'd have 100 grams minus the 44.79 grams. Okay, and so that's going to give us the 55.21 grams of excess calcium carbonate. Okay. So I'm kind of running out of room here a little bit, but this is a completed limiting reactants problem. So I know they're quite lengthy, but you do have three distinct parts here. And if you notice, you're reusing a lot of the same numbers. So although it is long as far as writing it out, once you get some of the work done, it's really not hard to just like rearrange it all. So it's a matter of what you're finding. So again, just a quick overview for part A on this set of equations is asking you to find which is the limiting reactant. So if you're provided two amounts of reactants, which one will limit your reaction from happening? So you take the given amount for both of them in two separate problems and convert it into the same product to figure out which one produces the least amount. Which product you choose does not matter. So we determine which one the limiting reactant is, say that it's the 45 grams of iron phosphate. So for part B is asking how much of each product can you make using that amount of limiting reactants? Well, if we start with 45 grams of iron phosphate, we already know from the first part in A that we can only make 46 grams of the calcium phosphate. So to finish part B, I need to figure out how much we can make of the other product. So we have our limiting reactant. That's always where we're going to start once we identify it. I'm going to convert this into the other product to figure out that we can make 43 grams of it. Okay, so now we know how much we can make of each product based off of the limiting reactant. For C, since we know that this is limiting us, we're going to have something left over of the other reactant. So you're going to start with your 45 grams of iron phosphate, convert that into the other reactant. Okay, so we know this is our limit. This is our other reactant that we started off with. That will tell you how much you're going to use up of the other reactant. Then the last step is to find the difference between what you started with, what you're going to use up to find the total that's left over. Okay, so hopefully this is helpful. Like I said, this is number 2 on the limiting reactants practice questions. So if you want to just pause this and use this as a guide or copy it down, that's fine. Number 3 and number 4 are done in the same steps. The only difference is number 3 is a little bit shorter because you only have one product, and number 4 is also a little bit shorter because you start with moles instead of mass, so it's like one less step. So I know this has been a very long video, but hopefully you're still watching it and understanding. So give this a try. If you're still not understanding, let me know. Try to be specific of like what parts you're not getting. So like if you don't understand like why we put this here or like where these numbers came from or something like that, let me know because that part will be important. So that'll be important for me to help you. So give them a try, let me know, and hopefully hear from you soon.